Okay, we're going to take a look now at how we relate trig ratios to coordinates of the Cartesian plane. So we do this using a circle that is centered at the origin and has a radius of 1. Okay, we call this the unit circle. So when we measure angles on the unit circle, they're measured from the positive x-axis, so this here, in an anti-clockwise direction. Okay, so for example, if we wanted like this whole angle here, that would be 90 degrees, or pi over 2 radians. This would be 180 degrees, or pi radians. All the way down to the negative y-axis would be 270 degrees, or 3 pi over 2 radians. And back down to the x-axis, we started sort of at 0 radians, and that is now 2 pi radians. So in this video, we're just going to take a look at sine and cosine. So if I take any point on this unit circle, I'll call it P, that point has coordinates x, y. Okay, now I know that that distance there from the origin to the point must be 1, because I've said I've got a circle of radius 1. Okay, and if I make a right angle triangle here, I know the base of that triangle has to be length x, and the height of the triangle has to be y. So here's my angle theta, and using my trig ratios, so if we remember SOHCAHTOA, okay, I know that the sine of any angle is going to be equal to the opposite, which is whatever the value of y is, over the hypotenuse, which is 1. Okay, so that gives me that sine of theta is always equal to the y coordinate. Okay, similarly, if we take a look at cosine, the cos of theta I know is the adjacent. So in this case, the adjacent side is x over the hypotenuse, which is 1, or just cos of theta is always equal to the x coordinate. Okay, now we're going to take a look at some exact values using these properties here. So sine of theta is always equal to y, cos of theta is always equal to x. So now if I take a look at some specific angle measures, I've written them first in degrees, and then we're going to also take a look at them in radians, because we want to make sure we can go back and forth all the time. Now, remembering that the cos of theta is always equal to x, and the sine of theta is always equal to y. So if I look at 0 degrees, so this is the x-axis, we start at the x-axis. If I'm moving 0 degrees, okay, I'm at this point here. Okay, that means that the cos of theta is equal to the value of x. So that means that the cos of theta is equal to 1. Okay, the sine of theta is equal to my y coordinate, which is 0. And you can check that by putting that in your calculator, either in radians or degrees. If you put in cos of 0 degrees and press equal, you'll see it equals 1. And if you put in sine of 0 degrees, you'll see that it equals 0. Okay? Now let's take a look at what happens when we go to 90 degrees. So 90-degree angle, so measuring from the positive x-axis, remember, anti-clockwise, would be this point here. So now, just remembering that 180 degrees is pi radians, so 90 degrees would be pi over 2 radians, or half pi radians. If we want to calculate the cos of 90 degrees, again, we're looking at the x-coordinate. So the x-coordinate now is 0, and the sine of 90 degrees is the y-coordinate, which is 1. Similarly for 180 degrees, so that would be all the way over here, or pi radians. The cos of pi radians is going to be equal to -1, and the sine of pi radians is going to be equal to 0. Now 270 degrees is all the way down here. That's 270 degrees, or 3 pi over 2 radians. Oh, sorry, I'll write that in here. 3 pi over 2 radians, or 1.5 pi radians. So in this case, cos of 270 degrees is 0, and the sine of 270 degrees is -1. Okay, and now if we go all the way back down to where we started, so now we're at 360 degrees, you should see that that's going to be equal to exactly the same as 0 degrees, okay, because it's the same angle. And that gives us that the cos of 360 is 1 and the sine of 360 is 0. Okay, and you should see that now if I kind of kept going on and on. So I'm just going to erase some of this in here. If I wanted to do, say, another 90 degrees, so say I was looking at the angle 450 degrees, or in terms of radians, that's the radians, that's the angle 5 pi over 2. That's the same. So 450 degrees would be measured like this. That's 360 degrees. I need to go another 90. So that's that angle there. That's exactly the same as the angle 90 degrees. So again, my cos of 450 degrees is going to be the same as the cos of 90 degrees, which is 0. Same with sine, that's going to be 1. So we get this property here that the sine of 2 pi, so 1 complete rotation, plus theta, is just equal to the sine of theta. And the cos of 2 pi plus theta, so 1 complete rotation plus another angle theta, is just equal to the cos of theta. Okay, so we're going to use what we know now to work out the values of these angles without using a calculator. So this is something that would come up on your non-calculator paper. So the sine of 270 degrees, so if I just draw myself a little axes here, 270 degrees is there. And the sine is going to be equal to whatever the value of y is in this case. So remember, that would be the point 0, -1. So the sine of 270 degrees is just -1. And we saw that in our table before. So if you just remember that, then that's fine. Now this one here, cos of 5 pi over 2, that's going to be the same as, we need to write this as a mixed fraction. So the cos of 2.5 pi. Okay, that looks a little bit messy, so we can write that as cos of 2 pi plus another half pi, or pi over 2. Now we know though that the cos of 2 pi plus any angle is just going to be equal to the cos of that angle. In this case, pi over 2. So pi over 2 we know is 90 degrees. So the cos of 90 degrees, or pi over 2, is going to be equal to the x-coordinate at that point. That's the point 0, 1. So the cos of 90 is going to be equal to 0. Okay, the cos of negative 180 degrees, the way that you measure negative degrees is that instead of going anti-clockwise, we go clockwise from the positive x-axis. So negative 180 degrees would be 180 degrees clockwise. And you can see that that's the same as the angle 180 degrees, positive 180 degrees. Okay, that's the same angle as doing that. So that means that the cos of negative 180 is equal to the cos of 180 degrees, which we know is equal to -1. Okay, so now you can go on to the classwork. We're now working on chapter 6b.